Good afternoon. How's everybody doing? Good. You have to make noise because I cannot see you. Hang on. Okay, now I got you. No, that didn't help. There we go. All right. So, my name is Eric Johnson. I'm a principal developer advocate at AWS, and I have the wonderful pleasure of introducing my buddy Brian. Brian, tell me who you are.
Hello, everyone. Thanks for having us. I'm very excited to do this talk with Eric. My name is Brian Zambrano. I am a specialist solutions architect for serverless, and looking forward to talking to you all.
All right. We are excited to be here. We are both EDA nerds. And if you're not familiar with EDA, that's event-driven architecture. We love this stuff. We love serverless, and we love sharing about this. And today we're going to be talking about, what are we talking about? Here we go. Event-driven architecture at scale, managing millions of events. Now, before we get started, how many of y'all have heard me speak before? Okay, several of you, but not enough of you that we can forego the rules. So there are a couple rules when I'm talking that I need. Do you know the rules?
I know the rules.
Okay, all right. So you follow them?
Yep.
Okay.
All the time.
So these are the rules. They're not really rules. They're more guidelines. They're going to help you out. But the first one is, this is any number I want it to be. Okay? I may hold this up and say 7 or 20 or whatever. A lot of times going to a restaurant, table for 10. I sit by myself at the bar. This is any number I want it to be. Okay? The second rule is these are quotes, not apostrophes, because this looks dumb, right? So I can't tell you. It's like, is he doing a bunny? I told you it's the same jokes if you've seen this before. So, but it's important for everybody to know. And the final rule is these are thumbs, right? These are thumbs because this will get you beat up, okay? So I do this a lot. I'm like, hey, things like that. So I was born this way. I'm very comfortable this way. I make a lot of one-finger jokes. However, and this is the really important part, if that makes you uncomfortable, I'm also comfortable with that. So I'm good either way. We're going to have a lot of fun. You'll notice that Brian and I are twins, basically. We basically are twins except for he has thumbs. That's where it comes out. So, but you ready to get started?
Yeah, let's do it.
All right. So let's get into what we're going to talk about today. So we're going to get into a few things. We're going to talk about what is scale. You know, we talk about scale. It's like, well, what does that mean to you? What are we talking about? Are we on the same page? What is EDA, which I just kind of talked about there? Event schema enforcement and evolution. We're going to talk about event schema management and discoverability, observability, and then we'll wrap it up. All right, so I'm going to get started here. We're going to talk about what is scale. And it's funny because I can ask everybody in the room, and I can go. I think we found out there's 256 people that this room seats, and I could ask you, and I may get 256 answers. Like, well, it's this or that or that. So, and we think about what is scale. Now, one thing we think about in scale is we think about traffic, right? And hopefully, if you're running a startup, you're growing this fast. Right? If you're not, I'm sorry, but this is a fast scale, obviously. When we say scale, we usually think of traffic. Well, we've kind of got you covered there, right? When you're running on AWS, we have a lot of really strong, powerful services that handle a lot of traffic. And these are just some interesting quotes or statistics. During Prime Day 2024, DynamoDB peaked at 146 million requests per second. If you're not familiar with Prime Day, there's a little startup company called Amazon.com, right, that runs this sale called Prime Day, right? It has to do with mathematical stuff. I don't know. I can't count past 4, right? I could get to 4, but I have to take my shoes off. It's weird. So, okay. So AWS Lambda handled over 1.3 trillion invocations during Prime Day. Right? AWS Lambda processed tens of trillions of requests each month. You get the picture. We do a lot of things for scale. So if you're building an application that's going to have a lot of scale, serverless and AWS is the way to go. But this is not that. Okay, well, that's not what we're going to be talking about today. You're like, why did we even tell you that? Well, I wanted you to know that we still care about that, but this isn't what we're going to talk about. Okay? Another thing we talk about in scale is architecture, right? In architecture and the teams that manage it. And when we look at this, successful EDAs do not generally look like this. And I use EDAs like that. That's just kind of a common term for applications built as event-driven architecture. And they don't look like this. What they really look like is something like this, right? There's teams all over the place. In fact, there's teams all over the world, right? And you have time zones you deal with. You have, different languages you deal with, all kinds of things, and you need to manage those. And we're not really going to be talking about the teams, but we're going to focus on this thing that was flying around. We're going to focus on that event, right? Because when we think about event-driven architecture, it's all about the event, right? An event-driven architecture is the event, and the health of the event are critical to the success of the application. And this event and applications are built, a good event-driven architecture is a decoupled architecture that relies on events flying around. And if those events go south, your application goes south, right? I'm not saying south's a bad thing, but in this, south's a bad thing. Right? Okay, so this is what this talk is all about, is the health of that event, the health of the schemas, and how do we deal with that, okay? Now, I've been talking about EDA for a little bit, but really quick, we're going to define EDA, all right? Now, very honestly, this is probably going to be the most technical part of the talk, would you say?
Absolutely,
okay.
yes.
So if you're going to write something down or take notes, I'd probably get your pencil and pen or paper out right now, because this is really, really important, all right? So I'm going to define event-driven architecture like this. Something happens, and we react. Did I go too fast? All right, I'll back up. Let's do that again. Something happens, and we react. Okay, so this is silly, right? But the idea here is that's event-driven architecture. You're like, Eric, that's super simple. Yeah, it's pretty simplified. But the idea that events or applications rely on events happening and events being passed around. This is that kind of base point of event-driven architecture. So what does an event look like? All right, so it's really critical that, that we kind of understand. So the events are signals, so we define them. They're signals that something or a state has changed, right? A system state has changed. Events occur in the past. They aren't what should be, they aren't what are, but they are what happened. Maybe they are still what are, but that's getting into wordplay right there, right? Events cannot be changed, they're immutable. You can't go back and go, that didn't happen, but yeah, it did. Now, you may do so. You may add another event to override it and say, actually, this is what happened. But events are immutable. It's a trail, right? And event schemas are the contract between the producers and the consumers. And this is a really important point, because a lot of times, how many of y'all work with APIs? Okay, yeah, the whole room. Like, we're developers, duh. Yeah, exactly. You work with APIs, and when you work with an API, you have a contract, right? The API says, you have to send me this, and I'll do this. Right? If you don't send me this, guess what? I won't do this, right? There's a contract that goes on, and it's the same with event-driven architecture. When your producers send out events, the consumers are going to expect a specific format to that, right? And when you start going away from that, that becomes problematic. Right, so I've got an example event here, the source pizza.service.com, the order created, and if you look down here, the name of the order is no pineapple on pizza, which is the perfect pizza. I'm just saying. It's not the point of this talk, but there shouldn't be pineapple on pizza. Right, so you can see food, proper pizza, pick up those kinds of things. This is an event. It gives you the metadata, there's some information about the event, and then it gives you the actually data itself, channel ID, different things. This is from, at least would be an order, right? So you think about how that works and how that event works. All right, so we've defined EDA, we defined that it relies on an event, and we looked at a little bit of what an event looks like. Now, Brian's going to jump in. He's going to talk about schema management and how that applies here. What do we do with this?
All right, thank you very much, Eric.
You bet.
Just real quick, I wanted to go through the genesis of some of these topics here. So I've been working with event-driven architectures for about 2.5 years now. And so a lot of these topics come from my time speaking with customers and hearing the same questions come up over and over. And frankly, some of these patterns have come from the field. So we've seen customers develop some of these patterns and ideas. So before I get started with some of the details, let's just level set. So Eric covered what an event-driven architecture is. I wanted to go over a little bit about what are the components of an event-driven architecture, just to level set. So really simply, of course, we have data producers. So these are the systems that are producing events. So these are going to be your applications, maybe publishing an event that has to do with something about your business. It could be a time-based trigger. It could be really anything. So we have the data producers on the left. On the right, we have the data consumers. So these are any systems that are going to receive that event or fetch it and then do something with it, right? That's the right side of Eric's very complex diagram earlier on. We do something with that. These are the data consumers. And in the middle are the brokers. So these are the messaging brokers. So real basic stuff, right? 3 big components here. So we're going to be coming back to this throughout this talk, at least as part of the talk. Now, with event brokers, there are 2 major categories, right? The first one is our pull-based brokers. So these are things like any kind of a queuing technology. So, are people here running, RabbitMQ, MQ, SQS, things like that? Show of hands. Right. So these are things that these have been around for many, many years. We're familiar with them. So those are, again, pull-based technologies. So the messages go on there. The consumers have to go out and fetch the data, pull it down, and then do something with it. The other category, in the same category as pull-based, aside from queues, are streams. So these are things like Kafka, Kinesis, MSK, the managed version of Kafka. So the broad category then, again, here is they are pull-based technologies. The consumer has to go out, fetch them, and then do something with it. The other category is push-based systems. So these are things in our world here is going to be EventBridge and SNS. These vary quite a bit because the message is actually delivered to the consumer. So the consumer, things like a Lambda function or an API, the message shows up automatically without them having to do anything. So very often people will ask me, hey, should I use EventBridge or Kafka? And where I always start with this is that these are 2 very different technologies because the way that they interact with the messages and with the consumers is different. One's a pull-based system and one is push-based. So for this talk, I'm mostly going to be talking about EventBridge. And I will make note of when things might vary. Overall, though, these patterns and these concepts are applicable to pretty much any broker that you're going to be using. But I just wanted to again, level set here. So Eric mentioned loose coupling. So in most modern day brokers now, we have a producer on the left. There's some payload. There's some schema associated with this. So the producer has some payload that it wants to deliver to the consumer. So it is going to push that over to the broker. The broker will happily accept this. Doesn't really matter what it is. And it will either deliver that to the consumer if it was a push-based system, or the consumer is going to fetch that if it was a pull-based system. And everything is good. That's pretty easy. However, what happens when a part of our payload changes? So here, make note of the order ID. So you notice here it's a string, and the telephone number is also a string. So what happens when this changes slightly? So here, the order changes from a string into a nested object, and the phone went from a string to a null value. Now, accepting null or a string, that's probably pretty easy, but going from a string to an object, that's quite a big change. So what happens there? Typically what's going to happen is that the event broker will very happily accept this. Like there's really no problem with this in terms of transferring it over to the broker. However, the consumer would need to know about this or have some logic that is actually going to be able to handle both versions of this payload. So if in this case, probably what's going to happen is that the consumer is going to break. So it's going to throw an exception or something else bad that you do not want to have happen. So again, the take home here is that I hear people say, hey, we want to use an event-driven architecture because we want to have complete decoupling. And that is not quite true. We have loose coupling, but that does not mean no coupling. So whenever you are publishing events between producers and consumers, they are loosely coupled in that they're not talking to one another directly. However, you do have an implicit contract. As soon as you start publishing events, you have an implicit contract that you need to abide by. So it's still very possible to break your consumers with a small change in your payload. And going back to what we were talking about at the beginning, at scale, you could have hundreds or thousands of consumers that you don't even know about. So I've worked with customers who say, these other guys, maybe we're in the US and they're in India or Australia and North America. They may not even know who is consuming these events. So you could be making a change on your side if you are the producer and breaking someone that you don't even know that team exists. And so this becomes problematic at scale, where scale means the number of people who are consuming these events. So if you distill this down, what are your options to solve this? So the first one, which is pretty basic, is a pinky promise. It's a promise from the producer. So the producer can say, I'm going to publish a well-formatted payload, and I promise it is going to be the right thing. I am not going to break anybody, and you can just trust me. So we're going to get into some of the details here, but that's one way. Again, we're breaking this down. We can deal with this on the producer side. In the middle, at the broker level, you can do something with enforcement. So at this point, the broker now becomes a traffic cop. So in the case of a well-formatted payload, the event broker will let that payload through and go out and publish it to the end consumer. Or in the case of something that is invalid, the event broker will reject that and radio back to give a notification to the producer saying, hey, what you gave me is not well formatted. I am not going to accept this. So the event broker now becomes the traffic cop, or the mediator of valid and invalid events. And then on the other side, the last part where we could handle this is around application level validation. So that is, the consumers of this would accept the event, do some sort of schema validation on their own, and then have this, work with that however they see fit. Now that can become problematic at scale because now every single consumer would have to do this. So before I get into some of the solutions for this, the details, I do want to cover, just note, some of this is going to revolve around JSON schema. And if you're not familiar with JSON schema, what it is, it's a definition that allows you to define and actually enforce or validate JSON payloads. And so here, it's a very simple object having to do with a pet. So you can see, it's pretty readable. The properties in here are an ID, which is an integer, and then the type is a string, and there's an enumeration, which for valid values for that type. And then you can see also the price is a number that has to be between 25 and 500. And so JSON schema is a tool that allows you to validate payloads, JSON payloads. And I will note that it solves a lot of problems. It will not solve every single problem you have. So for example, you wouldn't be able to do something that says, if it's a dog, then the price is this, otherwise it's that. But it will solve several of the challenges that people face with schema management. So here, the first thing that we can think about is pushing out the validation of the payload to the edges. So in this diagram, what it's showing is that the producer can actually reach out to a central repository. So it would be some shared library that you're probably going to have version controlled and put into a place where both the producer and consumer can get at it. Pull that down and actually validate the payload before it's being published, right? So the nice thing about this is you could do this with JSON schema. You could use something like protocol buffers. So whatever mechanism you want to use for the schema validation, you can use here. And like I mentioned, you can do this on the producer and on the consumer. So shared library that both the producer and the consumer have access to, and you're doing the validation either before you're publishing, in the case of the producer, and on receiving the event in the case of the consumer. And if this was me and I was just getting started with this, I would probably start here because it's fairly simple, right? There's not a lot of moving parts. There's no infrastructure to manage. And I think the mental model is pretty easy. The challenge here is that you're going to have to get, again, at scale, you're going to have to get all of your teams to onboard with this method. So that's one of the challenges with this. So let's look at a different model. So let's look at that schema enforcement. So how can you do this? And for this example, I will go back to EventBridge. So with EventBridge, typically what we're going to do is, or not typically, but what producers usually do is publish an event to EventBridge. And there's one API for that. That's called put events. So you can publish any JSON payload that you want. The change here is that rather than publishing to EventBridge directly, what you can do is push an event, or rather publish an event through API Gateway. Now, why API Gateway? API Gateway has a feature called API Gateway models. And what a model is a JSON schema definition for a particular endpoint. And so in the case of an event that shows up to API Gateway, it will do the validation for you. It will reference that JSON schema. And if the payload does not match the expected schema, it will then reject that. And so you will get I forget it's a 401, but you will get an error code back from API Gateway. So here we're leveraging API Gateway to be the traffic cop for us. Now, in the case of a valid payload, API Gateway says, great, I've received this, the validation checks out. Now you can have API Gateway forward that event onto your EventBridge event bus, and then have EventBridge push that out to all of the consumers just as you would normally. All right, so what does this look like? So under the hood here are a few screen grabs of where this is in the console. Again, you're probably at scale, you're going to be wanting to do this with some sort of infrastructure as code. But in the method request, if you look in here in the console, you'll see here at the bottom, there's this thing called request body. And for a particular content type, which for us is going to be application JSON, you can reference a model. In this case, it's the pet model, which looks just like the one I showed a few slides ago. So that's the first step. So once an HTTP request is made, API Gateway will do that validation for you. And then right here, if it does not match, it's going to get rejected. OK. In the case of the payload validating, then what happens? So it goes into the integration request. So the integration request is where we can have API Gateway forward the event onto our EventBridge event bus. So if you look down here, a great man once said, and that great man is Eric, this is VTL code. VTL code is not for the faint of heart. However, once you have it working, it will work. And so there's most of the stuff in here you can sort of ignore. But if you look in here, you'll see there's a second to last line. It says event bus name. And that is the event bus that we're actually going to have API Gateway forward our event to. So again, I was able to do this with some infrastructure as code. We've got a great blog post that deals with some of this, and there's an accompanying GitHub repository for it. So this is possible, and you can go out and find those resources later as well. OK, now, can you wrap these things all together? So if you were really, different organizations have different requirements. So can you do all of this? Because I've talked to some customers who've said, we want to do this everywhere. We want to have the traffic enforcement or the traffic cop pattern, and we also want to validate before and after. So they want everything. So you can still do that. I mean, this is a composition of different solutions. And so you can do this JSON schema validation at the edges. There's nothing stopping you from going out and fetching the models that are stored in API Gateway, pulling those down, just like we did with the first version, and then validating those before publishing the event to API Gateway. And then likewise, on the consumer side, you can pull that down from the API Gateway models, do the validation on the receiving side. And then typically, I would say, at scale, you probably are not going to be wanting to make API calls to fetch those. So you probably want to store those in some place like an Amazon S3 bucket or some other place, and then do some caching, right? So this would be the producer pulling that schema from S3 somewhere else, caching it locally, and then doing the validation before publishing. And then with this type of model, you're probably going to need to have some sort of I would say, fairly complex CI/CD pattern to line these all up and to synchronize the models that get deployed to API Gateway and the final destination to actually allow producers or consumers to download those. All right. Just to show you this is not that complicated. The validation part is not that complicated. Again, this is with JSON schema. I think it would be the same with protocol buffers or something else. But this is just some very simple Python code to show what it would be like to go out and fetch the model, pull it down, and then validate it. So the first thing is we have to go out and create an API Gateway resource. Again, this is Python, so this is Bodo 3. Once you have that model, or to get the model, you actually have to provide the API ID and the name of the model. Once you have that, you can literally just pull down the schema, which is the JSON blob that I showed you earlier. And it's one API call. This does the JSON schema validation client side, or for that matter, on the consuming side. All right. So now that we have some idea of how we can actually enforce these, what about when things change? Because it will happen over time. The schemas will change. Things will evolve, right? You're going to have something, new fields will show up. other ones might go away and be deprecated. The shape of the schemas might change. So how do you deal with versioning? So this is an event. It has an ID, a type, an adoption fee. Who has events that look like this, that are this simple? Probably nobody, right? This is the data. I would call this is the business event, if you will. But what we recommend is take your actual payload, the actual business data, and wrap it up into a field, a nested field. It can be called detail, it can be called whatever you want, but wrap up in something that's nested. The reason why is because we also recommend publishing some metadata. So that is the data about your data. So the detail wraps up the actual payload that your application, your developer, or your end users care about. And the metadata field is going to wrap up all of the other data. And in a second, I'm going to show you, this is where we're going to wrap up all of the version data. So what that looked like would be something like this. So we are good citizens for event-driven architecture. So in here, we have a correlation ID, right? So that is something that we're going to use for distributed tracing. We have an item potency key. We'll use that so that we can process events that show up more than once. We can process those one time. And then now we have some new fields in here which have to do with versioning. So the first one is, it literally just says version. And so what this says is that this event is version 1, and the detail has all of that payload, and that represents version 1 of this event. Furthermore, we have a downloadable schema, which, again, clients, either producers or consumers, could use to pull down and validate this payload, which is wrapped up in the detail field. Okay, so that's pretty simple. But what happens when things change? What happens when things are when we have a new version of the schema? And before we get to that, this one has 2 fields here. And here I just called them TTL, and you can call these whatever you want, but I think these make sense, and people can probably make sense of what this actually means intuitively. But the TTL is, when does this thing expire? When does this version of the schema expire? And what is the next version? Is this, this one's 1, you can probably predict the next one's going to be 2. But here, because both of these are null, this version that we're looking at is good indefinitely, right? So we don't have a version 2 yet. So once version 2 shows up, things change a little bit. So the TTL goes from a null value to an actual timestamp. So this means, when is this version that I'm publishing here in the detail, when is this going to expire? And here I made up a number, or dates rather, and it's April 1st. So if I was publishing this as a producer, I'd be telling all of my clients, this version is going to go away by April 1st. And depending on what's going on in your organization, I would make this as long as possible, right? You don't want to have it 10 years, but it could be a year, right? Because maybe it takes people that long to migrate. And the next version is version 2. And here's the version, which is again version 2, and here's a downloadable schema that you can use to download, look at it, inspect it, and then validate the next version of that. Okay. So if we have version 1 and we have version 2 ready to go, what are your options, or what do you do? How do you get people onboarded? And the answer is, you need to double publish. So the consumers, whenever there's a new version, are going to be publishing version 1 up until that TTL expires. And at the same time, they're going to be publishing version 2 to give consumers the ability to onboard onto this new version of that schema. All right. So we've talked about schema management in terms of how to enforce schemas. We've talked about versioning. I'm going to hand it back to Eric to talk about how to catalog and manage these schemas and these events.
Thanks, Brian. All right. So Brian was just showing a lot of technology on doing that. So it's going to surprise you. EDA is not really new, but it's really gaining traction. It's been around for a long time. AWS didn't invent it, although sometimes I take credit for it. But we did make it easier with services like EventBridge and Lambda functions and things like this. And so what's happening is there's kind of an ecosystem kind of popping up around, how do we manage these events? How do we manage these schemas? How do we document them? How do I let people know? So that's kind of what we're going to talk about. And how do we do governance on this and things? So there's a couple I'm going to throw you. This is not exhaustive, but some things to think about, and we'll start here. The first is infrastructure governance. Basically what this means is you provide deployable resources that you've already kind of tested and tried and true. You said, this works, this is the structure. It could be in CloudFormation, it could be in Terraform, it could be in CDK, those kinds of things. And it gives you control over the event structure from an infrastructure standpoint. This is what's going to kick out. This is what's going to accept, things like that. And this is most effective when you have control end to end, when you are the consumer and the producer and things like that. And one of the native services that we have for this is AWS Service Catalog. Is anybody using Catalog now? Okay, I think this is kind of an underrated service in a lot of ways. This allows you to build a library of services. This is the API endpoint I want to deploy. This is how the Lambda works. This is how the event schema should work. So you can deploy those out. And you can see here, you can have different portfolios that you can build, and then it allows you to build different products so that it has a bunch built in. There's a lot you can do that. Another one that's gaining a lot of traction in the field is this one, which is called Backstage. Backstage is anybody use Backstage in the room? Okay, yeah, all right, so we have some more hands there. And this is actually a good buddy of mine, talks about this quite a bit, David Anderson. David Anderson, he's the author of Creating the Flywheel Effect, really well known in the serverless community and in the event-driven architecture community. And his company at GP, they help customers build this out. But the main idea is we want to give our developers a place to start. You know, as developers, when we start at new companies, and it's really fun, it depends on the size of the company. But when we get there, they're like, here's your machine, good luck. It's like, well, where do I start? It's like, here's your machine, get started. Right, and so it's kind of tough to figure out where we get started. If we can hand them their machine, and here's the startup scripts, and here's the library of bricks that you can start putting together, and that's what this helps provide. So this is your starting point, right? So you can config, you can build these out. The next thing that we look at when we're trying to manage this is schema discovery. How do I know what a schema looks like? Is it schema or schema? What do you think? Okay, all right. I think it's schema. We're going to go with that. All right, so the schema, and how do we do that? One of the cool things is we want to do documentation, we want to do versioning, we want to do mapping, and one of the first things is Event Bridge Schema Registry. This is really cool because as events flow through Event Bridge, you can actually grab what those events look like. So many times we're like, I don't know what's coming in. I don't know what they look like. This way, you can look at it. And the really cool thing is I can drill down on an event, and I can say, okay, this is what the event looks like, and I can even download the code bindings. All right, so this is kind of on the inside for your developers, but this helps your developers know this is what I'm expecting, right? And here's the code bindings for it, right? So it's really critical to use the tools. We love to write documents. We love run books. We love things like that, and we like to point them to them, but they get outdated, right? Amazon, again, that startup I talked about earlier, internally we have wikis all over, and when you're looking on the wiki, and they're super helpful. There's a lot of pages that are really great, but there's a few outdated, right, would you say? And it's like, this doesn't even make sense. And so documentation is tough if it's not automated, right? And so use the tools for the automation. Another one out there in the third party kind of popping up is Async API, right? If you're familiar, we have Open API for API Gateway, right? We talked about how events and kind of APIs there's some similarities here. And Open API documents what does this look like, and then it also lets you test it. Well, Async API is looking to do the same thing. So as you're documenting this and you pour this in, you're able to kind of fill this out, and then it builds out much like Open API. It builds out like a test thing. All right, so this is a good one to look at. And then the final one, and this is going to seem like a shameless plug. It's not for me. It's for a good buddy of mine. But he's well known in the EDA community, a guy by the name of David Boyne. He used to be one of our developer advocates here at AWS. And he actually left to build a service called Event Catalog. And he's got a lot of large companies that are using this. And the idea behind Event Catalog is you document events. And it's really cool. You can say, this is the event that this service is creating. And this is the event that this service is receiving, right? So it has the events that are flying around, and what you're looking at here is a kind of a starting of the serverless espresso. Anybody have free coffee on me today at serverless espresso? I take credit. Did you hear me take credit for that? I'm not paying for it. All right. But Serverless Espresso, our team created that, and we bring it to reInvent, have every year since 21. This is what that event looks like, right? And this is what David has been working on to build. And so the idea here is, as you document this, you have, and it's basically a website. You can put it as part of your application, and you download it, you install it, and then you run it, and every time we change it, it builds and deploys, it creates a new app. And that way my developers can always say, what is the flow here? How do these events flow through? Because the reality of event-driven architecture is there's complexity. The reality of development in general is there's complexity, am I right? You're like, no, my stuff's easy. Okay, well, nobody else's is, right? There's complexity in development as we're trying to tackle hard problems. And so when we can use these tools to kind of manage those and get a good grasp on that, it's very cool. Now, with Event Catalog, you can see here, again, I'm kind of growing there. One of the cool things is I can say order processor, I can see the events it's kicking out, I can see, everything's being published. And then I can also go in here and I can drill down on the config changes, I can kind of build into these. But a really cool thing that he did is he said, I'm going to actually work with EventBridge schema registry, and I'm going to work with async API and connect. So let's say someone's doing async API on something, you have event schema registry, and we pull these in to build that out. Okay? I know this probably isn't the exciting part because it's not code, so to speak, but the more you can do for your developers to help them understand how things flow, how those work. We see teams that are using Event Catalog or one of the other tools to do their event storming with, or to do, as they build those out. We can look at how events flow before we ever put a line of code to page, right? And that's actually one of the things we're doing. We're looking at rebuilding Serverless Espresso and maybe some other services. And we're looking at it as, okay, we've got some new services, we've got some new ways things work. We're going to map this out. Now, is it perfect? No. But it's basically event-driven development, right? So I don't think I coined that. Maybe I did, but I'm going to take credit for that. Definitely. EDD right here. Yep. Eric-driven development. Just kidding. So event-driven development, has anybody heard of that before? Yeah, I'm totally taking credit for that. So, all right, nobody's heard, for those of you on TV, nobody's in the crowd's heard of it. So, all right, so this is the idea, is these are just some ideas, and there are plenty more out there. This is not an exhaustive list, but there is a community growing up around this. So, developers in the room, because I know you, developers are like, I'm going to just build my own, right? I'm going to build the next great authorization system, because there isn't one out there, right? We want to build our own. Use the tools. And I really encourage you, and these are just a few to look at. All right, so now that you've kind of learned about that, the next thing you want to do, and this is kind of towards the last of ours, but it really should be the first thing you think about. I'm going to turn it over to Brian. He's going to be talking about observability.
All right, thank you, Eric. Okay, observability. So Eric mentioned like event-driven architecture is very powerful. At scale, they are hard, and observability is one of those things that is hard to do at scale because you have independent systems working together, and you want to know the health of everything. So what is going on? So I'm going to go walk through a few things that are specific to EventBridge, and then go through a couple of other techniques to know about the consumers and what the consumers are doing. So the way I like to think about this is that, of course, there's the health of the producer. So that is let's just say it's an application. So what is the application doing? That's fairly easy to do, right? We all know how to build in logging and monitoring for an individual application. Then there's the health of the consumer. So we'll assume that that's another application. Maybe it's a Lambda function, maybe it's a container, whatever. But again, we know how to do that. There's also the health of the broker. So that is whatever's sitting in between and brokering those messages. And then there's the health of the system. So that is the whole end-to-end. So is my entire application working as it should? And this is where it can get a little bit more complicated, especially if you start going from one system to another, through a broker to another to another. So there can be many hops in between where the event started and its final destination. So thinking back to AWS and the shared responsibility model, I like to think about it this way, is if you're using EventBridge, the health of your event bus, we have you covered there, right? EventBridge is a multi-tenant large system that we run for you. that you can use, and you can assume that we are watching that. And the assumption is correct. The service team is always looking at things and making sure that the system is operating nominally. So you don't have to worry about the health of the broker itself. But from the producer side, how does the producer know if it's working correctly? Because you're now decoupled, you have that loose coupling with the consumers. How does the producer know that the consumers are healthy? What's going on with them? Are the events being consumed by the consumers? How long is it taking? And I hear that often. It's like, hey, X, Y, Z is slow, whether it's SNS or EventBridge. So we're going to get into that in a little bit. So thinking about EventBridge, and before I cover this, one thing I will say, Eric mentioned we are sort of like twins. We're both bald. We both love AWS. I am definitely not as funny as him, but I'm probably going to stumble over a lot of these metrics because the names are so long. So forgive me in advance. So monitoring EventBridge for you all. So if you're using EventBridge, what can you use if you're producing events through EventBridge as the producer? So here are a few, these are all counts. So these are all, what is my application doing? How many of these things are happening? So invocation attempts. So how many times have we tried to publish an event to EventBridge? Successful invocation attempts. How many times has that actually worked? Okay, because you can try and have that fail. Retry, are you retrying this multiple times? And then how many events are actually matching? When you're looking at metrics and thinking about observability, also really think about the dimension that you can operate on. So here you can do this by rule name. So we recommend having one target per rule. You can have it be in aggregate for a single event bus for all of it. And again, these are all counts. And because these are counts, you might want to start thinking about how can we look at a percentage, like what is the percentage of healthy invocations? And for that, you can use CloudWatch and some metric math. And so here, think about this, the successful invocation attempts, so that is, just like it sounds, the number of events that we've published that have successfully invoked a target, divided by the total number of invocation attempts. So ideally, these are the same. You want these to be 100%. You want 100% of the attempts to be successful. But again, using some very basic metric math, you can now come up with a successful invocation rate. So that is a percentage of these invocations that are working. So this is something that I encourage you to look at. Of course, you want to monitor this probably on a per rule basis, and you want this to be 100 at all times. But this is something that if I were running something at scale, I'd be looking at this, creating alarms around this to know that your consumers are actually getting what they need. Okay, the metric names are getting longer, so we're at kind of dangerous territory here. But what about failures? So there are 3 here that I've called out. Again, the dimension here is all around rule name, and these are also counts. So the failed invocations, the invocation sent to a dead letter queue. So a dead letter queue is a final destination in the case that a target was never able to be, EventBridge couldn't deliver a message to that. And then the number that were failed to be delivered to the dead letter queue. So all of these, you're going to want these to all be 0, right? In an ideal world, these never go above 0, which means all of your invocations are successful. The real world is very different. So these are things that you want to monitor. One thing I like to call out also is with the EventBridge, by default, it will retry delivery in the case of a failure. So by default, it will do that up to 185 times over a 24-hour period. What I like to tell customers is that once EventBridge has your event, that event is safe. So whether it's delivered or whether it's dropped to a dead letter queue that you configure, we will not lose that event. Okay, again, long names. What about latency? So how long is it taking from the time I publish an event to the time that my consumers are receiving that and then actually doing something with it? So there are 3 that are very long names. They're all around ingestion to invocation latency. So it's the complete latency, the success latency, and the start latency. And I'm going to describe these with a graphic because it'll be much, much simpler. So the first one is start latency. So what the start latency is measuring is the time between EventBridge receiving your event to starting to invoke the target, right? So you can see this graphic right here. It's not that the consumers actually received it and done something with it. It's just that the consumer successfully accepted that message. Okay, so that's the start latency. The next one is complete latency. So this is the time from EventBridge publishing an event to the consumer receiving it and then doing something with it. And here what these icons represent is the doing something, in this case, represents either successful processing or failure. It doesn't make a difference, but that is the time from again, between the first publishing and then that result, which is, again, it could be a positive or a negative. It could be a successful process or a failure. And the last one differentiates this now. The last one is ingestion to invocation success latency. So this one will measure the same starting point when EventBridge is going to publish that event to the successful completion of the delivery of that. So in this case here, the graphic is showing, imagine an event was published to a consumer and it failed twice, but the third time it succeeded. So what this metric would show in this case is the starting time and the time to the last successful completion. All right? So this will account for all of those retries. The first half of this, the measurement of publishing to EventBridge, that one is going to rest on your shoulders. So again, I have talked with customers who said, hey, we're publishing to EventBridge and it's slow, and like consumers, and it's really important to think about. You cannot just look at, I'm publishing something and it's slow over here, because there is so much, especially in an event-driven architecture, that goes on in between. So before you go in and say, like, EventBridge is slow, think about measuring this very discreetly in very fine grain, so that you know it's taking me this long to actually publish, it's taking me this long to actually process the messages. So really hone in on this and know where the latency is showing up, if it is slowing down, or if you are noticing any latency challenges. Okay, so what happens in the case that a consumer is having trouble, right? What happens if we've actually published a message, the consumer's having a problem? How do we get that information back to the producers? And again, I've talked with customers who've said, like, I want to know that every event I publish was successfully processed by the consumer. And we need to be careful here, because if you start thinking in that model, that is a synchronous model that we're describing there, right? So if you really need to do that, I'd recommend moving back to a synchronous processing with REST APIs or something like that. However, we can still get at what we need, and that is, how do we know when our consumers are having problems? We don't need to know that they have successfully processed it. We'll assume that silence means everything's fine. So we can start looking at patterns so that consumers can now radio back and say, hey, producer, I'm having a problem, and here are the details. So the first thing that you might think about was, well, maybe I could stand up an API on the producing side so that the consumers could just radio back and say, yep, this was a problem. I'm going to send you an HTTP post and give you some details about what the problem actually was. And that one, it probably at scale, you're going to start running into some problems, probably like you're DOSing yourself. And again, we're getting back into this synchronous model. And so I like to encourage customers, if you're embracing event-driven architecture, really embrace it. Like, really embrace the asynchronous communication here. And so rather than that, a better way of looking at this would be providing consumers a mechanism to publish their own event that has some details about the problem that they're experiencing, and then the producer can actually look at that, receive the event, and then do something with it. So maybe the producer has produced, they broke the schema, they didn't account for that. The consumers would have a mechanism now to emit their own events. I would recommend a different event bus for that the producers would be looking at, and then creating some action, like creating a CloudWatch event, publishing their own custom metrics about the errors that the clients are actually experiencing. All right. If you are using some sort of a central monitoring tool, so something like a Datadog or some of our other awesome partners, this does become a little bit easier in some ways, because now you can have your producers monitoring metrics that are put into your central platform, and the consumers will actually, again, publish those events or those metrics into that platform. So it's the same idea, but it's a meeting place now of metrics, so that you can communicate back and forth. Again, the main thing here is you want to give the producers a way to know whether the consumers are having any challenges. All right, that's a lot. We've got a
Yeah.
few minutes left. I'll hand it back to Eric to close this out.
All righty. Thanks, Brian. I appreciate it. Yeah, there's a lot of stuff we've thrown at you. Observability is huge. A lot of times I have worked with companies where I say, what are you doing to observe your application? Oh, we have a bunch of logs and we store them. What are you doing with those? We store them. So, okay, well, are you getting the story out of them? Right? So I really encourage you, think about observability from the very beginning. Write the logs, build the metrics. You can do metrics in IAC. You know, I'm kind of tagging onto yours. I'm gonna shut up in a minute, but I think it's super important that if your application's out there running, you're spending money for this to run, you want to know the story. You want to understand what's going on. So observability is huge. I really hope that this has been helpful to you. When we talk about scale, like I said, it probably wasn't the scale maybe you were thinking of, but this is the scale that a lot of folks don't think about, and it becomes a lot of heartburn as you're building applications. So hopefully this has been helpful. We have a few takeaways we'd love to give you here. Number one, build with EDA. Reduce coupling as much as possible. Number two, enforce schemas, right? Don't just, the whole trust thing doesn't work. Trust but verify, right? Yeah, I trust you, but I'm gonna check it anyway, right? Trust but verify. Understand the plan for your events and event evolution. Have a plan. Look at event sourcing. Look at these tools that help you plan these out. Monitor that. That'll save you complexity later. And start with observability in mind, which I kind of started with that already. We put a lot of resources together for you at this QR code, this short link. This is fun, this s12d.com. This is all built with API Gateway and DynamoDB with a VTL. And that's when I built it and I made the statement, VTL is not for the faint of heart. So, but it does work. I really encourage you to continue serverless learning. We've got some links here. You can get some badges. And then there's a couple other sessions that we encourage you to look at. Now, you're going to Monday. That's already happened. They're recorded, and hopefully you can see it a little later, but these are some to look at. Tomorrow, we've got building event-driven architectures using Amazon ECS with AWS Fargate. That's a shameless plug. That's my session. But we're going to be talking a lot about EDA. Then we got modernizing microservices with event-driven architecture on Wednesday. So those are some others to check it out. I'm sure you've got nothing else on your plan for the rest of the week, so here's some things to do. With that, Brian, thanks for letting me join you. I had a good time. Yeah, we had a great time. We thank you. We know you have a lot of things you can be doing. Thanks for spending time with us. Please fill out the survey and let us know how it went. Have a great day. Thank you.